So I'm pretty excited because I've got a whole bunch of new equipment in for making videos quickly. One of the biggest problems for me making videos is the editing afterwards, and so I want to be able to do them all in one take, like a class demo. And so I've got a couple GoPros, some nice microphones. I've got this little loop deck, which allows me to change cameras really easily, zoom in, stuff like that. So I'm pretty excited because I think that's going to be the key for me to make videos easily. Yeah, so I just wanted to get that out of the way. So something I thought would be a nice little pilot or test to this whole system is talking about this remote that I've got here. This remote goes to an electric fireplace that my parents gave me. They had it for a while and gave it to me, put it in my basement. It's starting to get chilly out, good weather, right? And it's only activated through this remote, which is really aggravating. I always like a nice button right on the thing. So I'm using the remote, or go to turn it on, and it doesn't work. So where do I start? Well, right, it's an old device. The best thing to do, take the batteries out, and sure enough, they were crusty. So I put some new batteries in, clean up the contacts with some sandpaper, could use nail file, something like that. And then when I push the button, it's actually nice. Now I can see a little indicator light on there. So that's some indicator that at least now this device is getting power. But now that it's getting to power, I'm still sad because the fireplace actually wasn't starting. So it means that I thought at least that there might not be something coming out of this remote. And the next thing that you can do to test something like this, that is kind of my go-to with infrared stuff, is to point my cell phone at it. Cell phones can see in a slightly different spectrum or cameras can see in a different spectrum than what your eyes might be able to. And so, like for example, if I point this remote at this camera, we don't actually see anything. But that's not 100% guaranteed as a test, right? Sometimes these output different frequencies, sometimes your camera filters them out, things of that nature. And so I wasn't entirely convinced that this remote wasn't working. And so that's why I ended up here to test things out and actually see if this is generating a signal. There's various spots that I could actually check this remote, right? I could take the board and take my oscilloscope and probe and see if my buttons are actually generating signals and if there's anything going to the light. Or I could just measure this whole device, like as one big device, and see if I have some sort of output. Because that camera trick doesn't always work. And so what I did, right, is I put this circuit together. I don't know why I have my headphones on, I just realized. But so I put this circuit together. And what it is, so I've got this kit here. It's this Elegoo 37 sensor kit. I'm not trying to plug them. It's just something I have on stock of a bunch of different sensors. And it's really useful because if you pair that with something like an Arduino Nano, you have a diagnostics tool that's very, very versatile, right? I'm basically using this as a little data acquisition platform right now. And so, right, this little module, right, so the sensor's actually right here. Let me give us a little zoom. Let's try that out. Oh boy, right? So there's the sensors actually right here, but it's on a circuit board, which gives us more of a module. And there's three outputs, or excuse me, there's three pins that I need to connect to. The G, which I didn't actually know what the G, R, or Y meant. I just went on the documentation for the sensors that I bought, and it said that G was ground, so I went to the ground of the Arduino. R was 5 volts, so I went to the 5 volts, and Y was the output. And so I just hooked that to an analog input, right? So the output of this guy is the input for the Arduino. And it turns out that all I had to do was give this guy a little bit of power, and so spoiler alert, but when this sensor receives a signal, it also has a little courtesy LED letting you know that it's receiving a signal, which is actually really useful. So, but now I still have this room to get curious and test this out a little bit more. I've already got it hooked to the Arduino, and so I'm curious to see what the signals might look like that's actually getting received. That's why I've got it hooked to an analog, just so I can see, is it changing voltage levels or is it saturating? What's it look like? So if we go to Arduino, whenever I'm doing something like this, I almost always start with some sort of example, right? These days you be able to use an AI tool to kind of help you start as well, but I like Arduino's examples quite a lot. And if I just go to File and then Examples, I can find this as like the very, very first example, Analog Read Serial. It's such a useful, powerful example. And I'm not going to get super into the code, but we do have our setup and we have our loop, right? So our setup only runs once, and all it's doing is setting up the serial so the Arduino can talk to my computer, right? It can send information across. Here, I'm taking an analog measurement on pin A0. Now that's an important thing, right? I need to go back to my, my wiring and make sure that my signal here that's coming out of this module is actually hooked to A0, and it is, right? I kind of knew that the example uses A0. So I've got this hooked right to A0. So I'm good with that. But mind you that the example does not necessarily know what it is that I'm trying to do. So I have to either go to what the example already wants, right? So to hook my analog into A0, or I need to change it to the pin that I actually did connect to. And then next, all we're doing is printing out that sensor value. We're sending it through serial so I can see it on my computer, and I'm just delaying. So let's give this guy a little shot here. If I upload it first, right, so I'm going to upload it to my controller. It's going to say done uploading, and now I can go to Tools and Serial Plotter, and this is super duper duper useful. I need to make sure I have the right baud rate here. The baud rate is currently 9,600. That's the bits per second. And here's what I see. A kind of rudimentary oscilloscope, or rudimentary is a relative term, but I can see right now that we're stuck at 1023, right? And that's the max value for the analog to digital converter. So if I put this remote, right, in the range of the sensor and apply signal, check it out. On our scope, we can actually see something happening, right? Something is getting received. But that signal is actually kind of a low resolution. I can't really tell much about it. I can see it going low and then back to high, and that's about it. And you can see that this signal is repeated, right? As if I'm holding this button down, it repeats. So what I need to do is kind of increase the resolution or be able to take samples faster. And so real quick, if I look in this loop, what's slowing me down? Well, one, my bit rate is kind of slow. I'm going to set it to be much faster. 250,000, right? So I'm setting my bit rate to be much faster, meaning that the signals now come through the USB cord much quicker. And I'm also going to remove this delay, right? So it's not always the best to do, but I'm not super worried about stability right now. I just want my measurements as fast as I can get them. So let's upload this. And if I go back to my serial plotter, I didn't really need to close it, but I do need to set my bit rate. I need to set my computer up to receive signals at that new increased rate. And now if I give it some signals, say like power, I can see a little bit more resolution. They're going by really, really, really fast. But I can see that I'm going 0, and then 1, and then back to 0. And if I change different signals, there should be something. Oop, is that guy not generating a signal? Doesn't look like that guy's generating a signal. How about this guy here? Yeah, so as I look at each one of these buttons, I should see something varying. And I see it going low, high, and then back. So it's going, well, here, let's look at the power signal again. Right, it's going low, and then high, and then back low again. And so there might be some sort of timing that's the real key here, and it might not necessarily be binary, but it's actually the timing of that high pulse or something along those lines. I'd have to do a lot of more careful measurements. But the real thing that I'm trying to demonstrate is just having a basic knowledge of Arduino and obviously electronics and programming can allow you to do some of these debug steps that would otherwise be unavoidable, right? I can't see this IR, but I can use these sensors in Arduino to measure it, which is a super duper useful thing.